During the 1980s, a group called Open Systems Interconnect, or OSI for short, attempted to create a logical arrangement for the various parts that make up a network. In the long term, their efforts were futile. Practically no one runs OSI protocols, but they did create a great model to explain how a network should work. The model is called the OSI 7-layer model, and it's a stalwart of networking theory. The OSI model is useful to know, but it's not necessary to memorize. It simply provides a theoretical model you can use for network problems ranging from design issues. This model allows any two different systems to communicate regardless of their underlying architecture. The OSI, or Open System Interconnection, model defines a networking framework for implementing protocols in 7 layers. Control is passed from one layer to the next, starting at the application layer in one station, proceeding to the bottom layer over the channel to the next station, and back up in the hierarchy. Layer 7, application, deals with the software applications that you use on your screen. Layer 7 is concerned with file access and file transfer. If you have ever used applications such as FTP or Telnet, you have interacted with an example of Layer 7. In the postal model, the application layer corresponds to writing a letter. Layer 6, presentation, deals with the way different systems represent data. For example, Layer 6 defines what happens when it tries to display Unix-style data on an MS-DOS screen. Layer 6 doesn't really have an analog in the postal model, but if it did, it would be like rewriting the letter so that anyone could read it, which, as you can see, doesn't make much sense in a physical context. Probably the best analogy is to a translator. Using the postal model again, assume that your letter is being sent to Mexico. A translator, equivalent to presentation layer software, can translate the data in your envelope into the local lingua mexicana. Like the letter in the example, data is mutable and protean and can be rearranged to fit the kind of computer on which it needs to run. Layer 5, session, handles the actual connections between systems. Layer 5 handles the order of data packets and bidirectional, two-way, communications. In a postal metaphor, the session layer is similar to breaking a single large document into several smaller documents, packaging them, and labeling the order in which the packages should be opened. This is where streams of data get turned into packets. Layer 4, transport, is like the registered mail system. Layer 4 is concerned with ensuring that mail gets to its destination. If a packet fails to get to its destination, Layer 4 handles the process of notifying the sender and requesting that another packet be sent. In effect, Layer 4 ensures that the 3 layers below it, that is, Layers 1, 2, and 3, are doing their jobs properly. If they are not, Layer 4 software can step in and handle error correction. For what it's worth, this is where the TCP and TCP/IP does its. Layer 3 network provides an addressing scheme. If you send someone a letter, you use a street address that contains a zip code because that's what the post office understands. When a computer sends a data packet, it sends the packet to a logical address, which is like a street address. Layer 3 works with Layer 2 to translate data packets' logical network addresses. These are similar to IP addresses, about which you'll learn in a few pages, into hardware-based MAC addresses, which are similar to zip codes, and move the packets toward their destination. Layer 3 is similar to the mail sort-in clerks at the post office, who aren't concerned with ensuring that mail gets to its destination, per se. Instead, the clerk's concern is to sort mail so that it keeps getting closer to its destination. Layer 3 is also the lowest layer that isn't concerned with the hardware. Layer 3 is where the term protocol really comes into play. The IP and TCP/IP stands for Internet Protocol. Layer 2, data link, by contrast, isn't physical. In our postal model, this layer represents a set of rules governing the actual delivery of physical mail. Pick up here, drop off there, and so forth. This is where the rules for Ethernet, token ring, FTDI, ATM, and so on are stored. It's concerned with finding a way for Layer 1 stuff, the cards, and hubs and wire, and so forth, to talk to Layer 3. Layer 2 is where network card addresses become important. Layer 1, physical, is similar to the trucks and trains and planes and rails and whatnot that move the mail. From a network perspective, this layer is concerned only with the physical aspects of the network, the cards, wire, and concentrators that move data packets. Layer 1 specifies what the physical aspects are, what they must be capable of doing, and, basically, how they accomplish those things.
Because you know I'm all about that bass, no trouble. I'm all about that bass.